In our previous video about high-precision GNSS on a Raspberry Pi, we showed you everything about setting up the actual GNSS module using our GNSS Flex system on a Raspberry Pi 5. Today, we're going to set up our RTK position, and we're going to be putting it into practice. Last time we used a monitor, keyboard, and mouse, but since we're going to be taking this on the go today, we've equipped it with a Raspberry Pi Touch Display 2, portable battery, and an antenna that is rated for use on a moving vehicle.
If we want to track our live location in PyGPS client relative to buildings, roads, and landmarks, we'll need to import a custom map. To do this, we're going to use QGIS to download a map of the area we'll be navigating around. First, open QGIS and select XYZ tiles on the left menu, and then select OpenStreetMap. Zooming in is a little difficult since it's hard to center, but once you have the immediate area you want to use as a map reference, you can export it. To do this, you first have to select Project, then Properties, then change display coordinates to Map Geographic with degrees. Then you'll export as an image. Make sure to take a picture or a screenshot of the latitude and longitude bounds at the bottom of the screen. You'll need these to sync the map with your location in PyGPS client when we import the map. Make sure you save it as a TIFF file, and then you're good to go. So we're on the home page of PyGPS client. We're going to pick the same parameters that we used before. Port 0. We're going to pick the right baud rate. We're going to connect via USB. So now we have to get an RTK fix. So to do that, we're going to go into the NTRIP client menu. There are a few different ways that you can sign up for this. Services like Point One have free logins that you can use or free trials for access to a base station. We have one at SparkFun, so that's the information that I'm going to put in. When I hit this button, so now it says we're connected to rtktogo.com at the Boulder SparkFun base station. Perfect. So now we can see up here we have an RTK fix, and we're getting really accurate data all from up here. It's a little hard to see on the small screen, but we're making it work. So here is where that custom map that we downloaded is coming into play. So I emailed it to myself and downloaded it on this Raspberry Pi, so we have access to the TIFF file. I'm going to import it into PyGPS client, so that way we can watch our real-time position superimposed on a map of the area. So we're going to select importing a custom map, select from our files. So I've got a few in here. I'm going to choose this top one. It's for the Boulder Tech Center. So this is the map that we're looking at. This is the area directly around the SparkFun building. So what we have to do now is fill in our maximum latitude and longitude that we remembered from earlier. And then we can import the map. So what happens with this, once we import it, is when we have latitude and longitude coordinates that fall within this map, and we have our map view set to this map, we'll be able to see our location as it would appear on this map. So now this little section down here lets us flip between different map settings. So we're going to flip to our custom map, and it's going to have the one that we just imported. There we go. So now we can select the box that says we want to keep track of all of our points. And we're also going to up our zoom so that we can actually see what's going on this little screen. So if we're able to look close enough, that is the SparkFun building right there. And we can zoom out a little bit and see the general area that we're in.
So we're going to be driving around the block around the SparkFun complex, and with any luck, we should see our little tag move around with us. Here we go.
So there's the track for our little loop around SparkFun HQ's neighborhood. There are a bunch of other settings on PyGPS client where you can log this data into GPX files. There's a bunch of different configuration options for that. So if we zoom into our starting and ending position, we parked in a different parking spot. And since we have such accurate location data from getting our RTK fix, you can clearly see the difference between those two data points. So you can get really precise with this level of positioning, and it's all mobile and on a Raspberry Pi.
The Flex system is a great way to bring high-precision GNSS to your Raspberry Pi or other single-board computer. You can pick it up from our website today. Happy hacking! GNSS, or using it,
Putting it into practice.
putting into practice. There we go, cool. All right. The Flex system is a great way to equip your, oh my God, hold on, let me think about what I'm gonna say, or other GNSS